Welcome to Spring LIB.
In this exercise, we have a train that's accelerating with an acceleration of 2.5 meters per second squared, and we have a bolt on the ceiling of the train that's dropped. And we want to find, in question A, what is the acceleration AR of the boat relative to an observer inside the train car. So notice that according to a ground observer, the boat has an acceleration downwards g, that's the acceleration of gravity. But according to the observer inside the train car, besides gravity, okay, suppose that the train car, let's say that this here is a train car, and suppose it's accelerating to this direction, in this direction A, okay. So the observer inside the train car will also say that the boat is accelerating to the opposite direction of their acceleration. Okay, because according to the observer inside the train car itself is at rest. So notice that we have the acceleration of gravity g, and it's perpendicular to the acceleration a, seen only by the observer inside the train car. So the relative acceleration, the total relative acceleration, is the square root of a squared plus g squared. A is 2.5 meters per second squared, and g is 9.8. So what we get is that this is equal to 10.1 meters per second squared. And also we need to calculate what is the angle of this acceleration. So in the end, what we have is an acceleration that's pointing somewhere like this. And I'm going to calculate this angle, theta. Okay, so notice that the arc tangent of theta, notice that I'm going to start by writing the tangent of theta, which is the acceleration a divided by g. So this is 2.5 divided by 9.8. So the tangent of theta is 0.255. And taking the arc tangent of 0.255, we have theta equals 14.3 degrees. Okay, so the magnitude of the acceleration is 10.1 meters per second squared. The angle is 14.3 degrees with the vertical. In question B, you have to find the acceleration according to an observer on the ground, okay, that is the acceleration relative to the Earth. And in that case, there's only the acceleration pointing downwards, that is the acceleration of gravity. So the acceleration AR, actually I'm going to write AE as the acceleration relative to the Earth. That's only the acceleration of gravity, which is 9.8 meters per second squared, pointing downwards. Okay, in question C, we have to describe what is the trajectory of a boat, of the boat, given that we have to describe the trajectory of the boat with respect to an observer inside the train car. Well, to an observer inside the train car, the boat starts with a speed v equals 0, okay, because it starts with the same speed as it had when it was released from the ceiling, and it had the same speed as the train car. But according to the observer inside the train car has speed 0, so the initial speed is 0, and it has an acceleration pointing to the southwest with an angle theta equals 14.3 degrees. So this means that the the trajectory of the bolt, according to the observer inside the train car, will be a straight line pointing in the southwest direction with the same angle with the vertical 14.3 degrees. Okay, so straight line heading southwest with an angle 14.3 degrees with the vertical. And in question D, we have to describe the movement of the bolt relative to the Earth. Notice that initially the bolt has a speed that is equal to the speed of the train when the bolt was released. So let's say it has a speed pointing to this direction. And there is, so this here is the initial speed vi, and there is the gravitational acceleration g pointing downwards. Now notice that in the horizontal direction, the speed is constant, and in the y direction, the speed increases with time. So for that reason, the trajectory will be a parabola. It will be a parabola with the vertical. So this here is the vertical. The trajectory will be something like this. Okay. So a parabola. And this concludes the exercise.